This is Old Man PHP. I create PHP video tutorials for the old guys who want to learn a new skill and compete with the young crowd. This is video number 112. Remember I mentioned that I was going to do a video, actually several videos, maybe 3 or 4, of the data structure and algorithm, which is that. Don't really have a document or anything like that, but I figured we'll talk about it. I'll write some stuff and then I'll give it to you in the description with some example, and then in the description below. And then on the following, we're going to break it down to different things like the tree, the array, the queue, the linked list, those kind of things, which I'm going to talk about today real quickly, giving you some more information. Maybe I'll write something down here. But that's what this picture is. How about if we create a file? So we'll do, and then we'll call it, what should we call it? We'll say big O notation. And then we'll say text. How about that? I'll let you have it. Okay, now we're going to say like this. We're going to say edit. Alright. Maybe I can move this a little bit so you can see the numbers and me typing. So how about we just say explaining, oh god, explaining data structure and algorithm. And then on the bottom one we'll say the big O notation. Alright, and then we'll break it down over here. So we'll say some few things. Look, I just want to say that the big O notation is like a mathematical notation, and you know, like that describes limiting behavior of a function. You know, so when you create a function with the for loop, you want to find out if we can, if it's scalable or not, and the big O kind of give you that mathematical, this little type of notation. So what it does is it describes the limiting behavior of a function, right? With the arguments that tends to like for a particular value, you know what I mean? Not more like infinite values. It could be just a value of 20 or infinite, right? So we use the big O to describe the performance of an algorithm. You know, when I was doing this, there was I bought a, because you know I always did programming of different languages and stuff like that. But big O, when I started talking about big O, I was just I thought it was like kind of like a big headache, because you can kind of tell if things are bad or if you can do a for loop that you. So there was a book that I bought. Let me see if I can find it here. Let's see. Let's see, I found it. It's green, by the way, and it's fat, and it's heavy. I love the book, because I bang it for my knuckles. Anyway, so it says cracking the coding interview, and it has like 189 programming questions and solutions. So, you know, and I'm reading this, and this is the 6th edition. It's fat. I mean, this goes to, I'm looking at the pages in the back, goes to like 695, maybe 98 pages. Let me see. What's the last one look like? Yeah, it goes to 695. So, and it's fat. It has a lot of stories, you know. A lot of stories about the big O. And when I was reading this stuff, I'm like, what the heck? How do you know? Oh, my book is breaking. Oh, I gotta fix this. I want my book to break. It's a good book. It has great stories, and it really shows you a lot. I mean, it's just crazy. But in the notation, and they use this thing called the O. You can actually use something else really, but they use the O. It's like something like because they use it to describe the performance of an algorithm. So this helps to see if an algorithm is scalable, like I mentioned, or not. So again, in the computer science world, it is used to classify like algorithm according to the how the running time and space requirements grow as the input size, and they kind of go like this and like that. And so basically they want to know, so so what happens is this, actually this is how it's written. It's written like this, like that. Is that a zero? Is that a no? Huh, let me see. No, it's a no. That's kind of weird. Let's see what a zero looks like. Oh, okay. Yeah, so the data structures, right, are specialized formats for like organizing, processing, and retrieving and storing data, such as which I'm gonna break it down in different videos. So one thing, because the reason why I'm doing that is because there's gonna be examples like arrays, linked lists, just like I talked about earlier. Something called stacks and trees and queue, right? So there's a lot of things that we have to talk about. So I'm gonna break it down in each one. And as I was reading the book, I'm like, oh man, how's that? And then one day I started to talk to some few people that I really deep into, these younger guys, and these were from I forgot. I think it was Silicon Valley. He used to work there because he came back to New York. He said things were so expensive over there, but the company. Well, anyway, the point is he was explaining things to me and how the algorithms, algorithm, right? So we've been doing it, right? It's like step-by-step procedures or formulas for solving a problem. Remember how you do the for loops and you do this and the different functions? That's what that is, really. Performing computation, like sorting. Remember we did that. Searching, we haven't. I think we did a video on searching, but I'm not too sure. But if not, then I'll have it, because I think I do have that one in the queue ready to go. But I just have to edit some few things. But we'll get that out soon. But right now we're gonna talk about this stuff, right? So together they are like fundamental in computer science for writing efficient programs, right? So you gotta know. That's why I always like the array, and I also like their databases because you can go back and forth and all. But arrays is really good because they got their. Well, I'm getting ahead of myself. Like an example, an array. You know an array, right? So I'm gonna keep this here, right? And I'll just put something like this is an example of an algorithm. You've been seeing it, but I'll put it in anyway. Algorithm flow in PHP. Now remember, this whole thing about the big O notation works for every language, and they got more of that big O than PHP, because PHP uses also certain type of like functions, like programs, outside programs that you can use. Anyway, before we do that, let's just do that and give you an example. It's like, for instance, you've been seeing this, right? You go like this, PHP. I know. I'm repeating myself, but I'm just doing it because I got to do this. So let's say you got a score of 85, right? And then the condition flow, right? The if and then. So the script makes a decision. That's your algorithm. So if you kind of went if score is less than equal to, my mother's 90. Yeah, I get 95. How about that? And then we go like this. Yeah, my mother reached 95, man. And she's doing okay. Okay. God bless her. Anyway, so we're here. Do this. Bitty, 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 bo, 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 bo. Sorry, I like to make noise too because I'm by myself most of the time. HO, then we do like this. Then you say grand. Let's say we do, this grade thing, right? The A and the B and the C grades. Let me see. We go like this. And then over here we could say, you know, matter of fact, how about if we put a space here? I'm gonna, all this stuff that I'm typing here, I'm gonna keep it in the description below so you can have it. Okay. So we'll say else if. Remember that one, the else if, and then we'll go. Let's do. Now we can keep it together. We can say score. I'm pretty sure you know what I'm talking about already. Equals to, let's say 80, right? That's the score. Let's see, 80. Then you go like this, and then you have another one. Let's say for S like this and this. Okay. So let's bring this down a bit. I think there's enough room. Let me see. So right here we'll say something like, what Google space? We'll say something like that. X. Oh, then we'll say grade. We're not gonna try a lot of these things because I'm typing these things and we're talking about it. Maybe we should. That's okay, because on the other ones, they're gonna have so many example. I will be trying it, and we're gonna be calling it up on the browser so we can see the results. But right now we're talking. I just want to make. Oh yeah, you know something? We said that this would be B, right? So this would be B. Then we'll go like this, and I'm gonna put this here. Remember, you can put comments on the same line. So I'm gonna say this line executes. Because 85 is greater than 80, right? Like that. Let's put a little dot here. What the hell? And then, of course, you go here and you check that one. And then you go, okay, so if it ain't, then we'll do echo, right? Let's put this here. C or lower. Now see, this is an algorithm. You get the grade, you want to find out what it is. A, B, C. If you feel like greater than 95, you get an A. Oh, that's too much. How about we do 0? If you're greater than 90, you get an A. If you like greater than that and this, that would be 80. That would you get a B. And then if you and if else, then you got to see. You know, I had a couple of bunch of C's too, man. Sometimes you do some work, blah blah blah. You didn't care. Things got busy. As long as I got a C, but I was mostly a B. I'm mostly a B guy, but I did have a bunch of A's too. So the code snippet is considered, and then this is like consider. See, this is kind of the number. So this is considered a. Let me just write this down. This is considered a. This is gonna be too long, man. This is considered a O1 like that. See, it's weird, right? Because they look at it, if it was like a simple thing, like maybe this, oh, this is considered, it's always O N, but nobody knows what the N is. But when you start doing this like this, it's considered O1. Because it's like time, it's a constant time complexity. So, I guess I can write that down. How about we put it over here like this? I could say constant time, because they always talk about time and space complexity. Because when you create stuff like for loops and stuff like that, or double arrays, and there are different types of calculation, they want to make sure that it's an O1. It's weird because, you know, when you look at these things and you see the different for loops and your calculation, your algorithm, you know, it works. You know, now normally when you're trying it out and you're messing around in the whatchamacallit, in the, you know, on your local host, you're not dealing with several, but when you're dealing with thousands and maybe millions of data, and if there's no problem and it's straightforward, it's always going to be considered an O1. believe it or not. So the big, let me just write that down. Let's see. So I'm gonna say the big O notation. I should have had this done already, to tell you the truth. 0, 1, that, right, which we just talking about, means that the time the algorithm, I wish I could type faster, takes to complete is constant. And it's funny because a lot of computers are so powerful, so it's just, I don't know. Then I used to say, okay, so then what do you do? I mean, okay, you do the calculation. What do? You're showing your supervisor or whatever, look how fast it is. You bring up your inspection, you look at the memory thing, and it's going very fast. So what do? You just say, oh yeah, this is a null one. I mean, I always find it to be a little silly, but hey, that's what they want, man. So long as you understand the data structure, that's what I always say. But I'm giving it to you now because I remember, I remember reading the book and, doing stuff. So I can just say, and then I can just say that, regardless of the size, how about that? That's what I write, of input. So basically, this here, I mean, this is simple right now, but let's say you're doing a big giant calculation, it's going like this, and it's just doing just a one if, blah, blah, and this is considered an O1. It's just a weird thing. This is considered an O1, right? So in your code, so the operation performed is like a series of simple comparison, like using this stuff here, the greater and equal one, right? And the output using the echo. Simple stuff. Now these operations takes like the same amount of time to execute. Whether the input value is like 50 or 95 or any other number, the code doesn't loop over the input recursively. Like, in other words, it's not calling itself, it's just looping through a thing, so it stops right there because it's only a few things. You're only doing, for the students, but it could be hundreds of students. But it goes fast. It's just the same thing. That's why it's considered an O1. So for them, it's like, oh, okay. So so the code doesn't loop over the input, right? So it doesn't call itself, and it performs any the operation whose time complexity is like depends on the size of the input collection, like an array or list. So if it only executes like one of the comparison blocks based on the single variable value, which is the grade, right? The 90 or the 80. And since the number of steps comparison and the output is fixed and does not change when the input value, this time complexity is 0, 1. That's all they say. It's just such a weird, I don't know. Maybe I should just write this up. Should I write those things down that I just mentioned? Well, you can run this video over again because kind of, maybe I should just put it here. Let me see. Do you remember what I said? Only, shucks. Like I said, executes, of course, one of the grades, right? And it's only a single variable, value, right? So since since the number what was it of steps, right, is fixed, and because you only go what you do either this or this, and maybe and this. That's it. It's all fixed. There's no. So you're not going to another thing like another for loop, or you're not doing any other. That becomes something completely different. Now, what was I saying? Ooh, let's step it over to this side, and then we'll say that it steps is fixed, and let me see, does not change with the input value. So should I say, so the time complexity, oh man, my ribs hurt, man. Complexity is, like I said, oh, and I'm repeating myself so that way it stays in your head. So the expression of that O1 in PHP as computer science in general, right, refer to the constant time complexity within the context of a big O notation. And again, the big O notation is a mathematical notation that describes the limiting behavior of a function when an argument tends to, well, it depends on what it, no, it doesn't. It's just a simple stuff like that towards a particular value infinity. So no matter how many times you, like it could be a, how many is a school? Schools usually has, I don't know, okay, let's say elementary school, I guess it has thousands of students. And then you're doing this calculation, and it doesn't matter because it's simple, so it's always going to be a O1. You know what I mean? I know I'm repeating myself, but so O1 again means, maybe I should put it here. The guy was telling me, my friend, like I keep telling you about, actually it's a couple of friends. Maybe talk about, because they do talk about this sometimes. So the O1 so means that, again, that and oops, that and algorithm, or you know, an operation, right? Because that's what that is, an operation. Am I spelling this right? That an algorithm operation will take a constant, which is, you know, this one right here, it's a constant. The constants, okay. Amount of time, of course, to execute. How about that? And it's regardless. Let me write that down real quick so you can get that in your head. Regardless, let me see. How you spell that? Regardless. It's with a D. Okay, regardless of the size of the input data, which is represented as n, like that. I'm gonna save this for you because I'm gonna put this in the description. We're gonna do, oops, sorry, wrong thing, we don't want to do that. Save it right here. Look at this, my new design. What do you think? You like it? If you like it, put in the comments below. Tell me that you like it. I love it. This took me a little while. We have to do these things and we replicate them and copy it and do that. Forget it, it's just another thing. So again, constant time, because this was the constant. Okay, the constant time. The constant time is fixed and it doesn't change on the input when the signs scroll, right? So it means that operation is dependent on that end. So if you're doing, so maybe I should put that down. Yeah. Let's see, the time. I don't think I could tape everything I said because I'm going to be here all day. Time again is fixed and doesn't change as the input size grow. That would be a good one. So it means that the operation is depending on what the n is. which is right now is one size. I don't know, it's just a weird way of explaining things. I don't know. I just I could kind of put here. I don't know. Let me see. So I was talking about the example. So like if the operation takes like 5 milliseconds for like 10 element array, especially when you're talking about arrays, and the 5 millisecond for that like I don't know, it could be 1,000, but then it could also be a million element array. Its time complexity is still going to be 0, 1, right? So just get that. Yeah. So the one in the O1, right? That represents the constant value. That's what that is. So the actual number of steps that might be to like to go to do the what is that notation, it could be 5 1, it could be 5, it could be 100, any other fixed number. But since the big O notation focuses on the rate of that growth, so they always worry about how fast it's going. Is it slowing down? Is it slowing the computer? I don't understand, because computers right now is just so fast. But I guess when it comes to this deep thing, which I'm going to be working on soon too, this huge thing. I mean, a whole, kind of like a bookkeeping thing. It's going to be good, man. I can't wait. And so, approaches and other constants are simplified as 1. That's why you always say 0, 1. So, like many fundamental operations in the PHP and other languages, that's what they use. They go, okay, buddy, take it easy. I'll take you out in a few minutes. It's a 0. It's an O1. Okay, so accessing an array, like for instance, accessing an array element, and like by index. Because remember, I told you index arrays are index. If you want, let's say 10, you got 10 elements, and you want that first one, it starts at 0, because it always starts at 0. The 10th one will be 9, right? So if you're accessing that 6th element, the constant time, regardless of any size, or accessing any object property, or accessing a property of the mathematics, is always going to be that O1. It's going to be that O1. It's just so crazy. Something I should write down. An example, like for instance, if you're accessing like this stuff here, dollar value, I don't know, just give it any name. Array. There's always going to be. Oh, that's not how you do it. Is it? Let's see, what was it? 5, I said? That would be 6. Okay. Oh, man. And accessing the property like this is, see these little things? Little simple thing. Oh, don't tell me the management is coming in. Oh, man, I can't get a break sometimes. I hope he skipped. I hope they get to me later. So let's say when you're doing an object like this, whatever property, remember how we were talking about that? That's accessing a property. Remember, this is how you access a property. Let me just write this down. Accessing a property. Access property. And every time I have to speak too much, man. So then when you do the basic of mathematics, right? The addition, the subtraction, the multiplication. Oh, shucks. Multiplication and like A equals B plus C, like that. Or checking the size of the PHP array using the count. Remember the count? When you use something like this, right? Just a crucial note that internally, like the PHP array, often stores the size of the property. So retrieving the size is actually a quick one, and it becomes an O1, which is wait a minute, I spelled that wrong. I wrote it wrong. What is it, like that, right? So the size of it, because when you, let's say you do an array, like for instance this one, where is it? Right now this is just 1. So the array size of value is just 1, really. It's just 1. So it's usually a quick O1 lookup, and then not a it doesn't. It's not a slow ON account. So if you got like I don't know, let's say if I kind of did this 1 through went to 100, no matter how, because it goes so fast, it's always going to be an O1. So it'll be an O1. So if you could say like, if you say something like, matter of fact, let's put it, how would I do this? How can I say this that it'll stay in your, so if I went like this, like for instance, dollar count and count is two different things, just remember that, guys. This is count right here, right? This is the function, then you say dollar array, like this. And this is a fast O1 lookup because it's quick. It looks the count itself will look at this, and let's say I've got a whole bunch of them, like I don't know, thousands. It'll give you a count real fast. I mean, it's so fast, so that becomes I'm gonna say it right here. This becomes a O. Did I spell that right? O1. So when you're looking at it, it's like, oh, so what if I can see it becomes a fast O1? How about that? Because I didn't mention fast O1 lookup. Yeah, that's it. Lookup. Isn't it crazy? And it's just described. So, but still, my point is, okay. Oh, you see this and you see that. So why would I have to use it? How do I go to when we're talking? We go, oh yeah, oh yeah. What are you gonna say? Oh, it's an O1. Or it's an O and the power of 2, which we're gonna come up with that in a few minutes. You know what I mean? It's just the way they explain it, how they would do the calc. I just mentioned that's what that is, right? So like when you're adding and removing an element, like at the end of the PHP, remember that? Remember the push and the pop when you do what's it called? Array underscore push and array underscore pop. Remember that one? And how you can like for instance, okay, let me just write this down, man. Let me just write this down. Adding or removing an element. Remember that one? At the end of a PHP array. Even though it is a PHP course, I'm still going to mention PHP array. Like the push. Remember that one? Slash pop. Remember that one? Oops. Oh man, I can't believe it. My ribs hurt. Went to the doctor. I'll find out I gotta replace my 2 knees. Oh man. Oh boy. And so basically, so I'm gonna write it down over here. I'm gonna say a array, and there I go. Boom. See this? I'm creating an array, and I'm adding some element to it. So I'm gonna say a new item, like that. Item could be anything, right? Or if you do array, like right here. Look, we already talked about this command, but we're gonna say array like that, right? So this one, in this particular one, this one's gonna be more like for adding. What is it? Adding an element, right? Remember that we talked about that, and then we got. Let's push it over here, and this is removing. To the last element. This dog is looking at me like, hurry up, man, I gotta go. Okay, let's see. So then this is this is considered, because it's easy, it's fast. Consider and O1. Because no other element needs to be shifted, right? And then the O1 is like the fastest possible time complexity. and is highly desirable for critical operation. The thing is, when you're doing um, when you do like a bubble, so remember how we did I think there's a video how I did the bubble sort, and I did it the way it's supposed, how you look at it, how the computer kind of does it. Even though it went fast because it's only what was it, 110, maybe 1 or 10 elements, and I just wanted it sorted. I showed you how it's done, how it moves the zero array to a box, and then you move that 0 1 into 0 uh, array. I mean 1 to 0, and then you take the one that's in the box and put it right back on what the number 1 used to be. That's how you sort it, and that's you doing it. Even though that was short, that was considered a 1. But if you got thousands and thousands, it's not going to be considered a 1. So what you do is you use the pop. You use the array pop in the URL to move things around, because now you're using a function that's more efficient than you writing things longhand. Like he says that, so that will always become like an O1. Okay, so that's it. I mean, the O1 is like I guess I could say it is. I could say is the fastest, I guess, possible time complexity, and is highly desirable. Yes, that's what I wanted to say. Desirable for critical operations, I guess. That's the word. That's cool. Oops, I like going that way. It's more like this. I like to condense stuff, you know. It just makes it easier for people. So we'll do this. We'll put a line there. So the constant, just to separate some thoughts. So the constant time. Sorry. So the constant time complexity, that denotes as a O1. Just remember that. So it means that an algorithm execution time that doesn't depend on the size of the input data set, which is the data set. I'm gonna say here data set. It would be like n, like that. So let's put it away. So what was I saying? Oh man, I forgot my thing. Okay, so the input data set is n, right? So no matter how large that input is, the number of operations that the algorithm performs remains the same. And so it's always going to be characterized as 0, 1. So the key thing is, maybe I should write that down. The key characteristics. Maybe I should say, I don't know. I think my wife's getting me pizza today. Oh man. So I guess the first one would be, I'm gonna put this like this. The first one would be, I don't know, fixed execution, right? That's what we talked about, the fixed execution. Execution time, right? Oh man, my eyes. And I could say that the time is the time is what should we say? The time is a constant, right? So for example, it might take 5 steps whether the input has a 1 item or 1 million items. So that's why it's always 1. So I say the time, yeah, I guess I could say the time constant. The time, let me see, I'll put it right here. The time taken, that's it, is constant. It's constant. So if it takes 5 or whatever, and this also independent from the input, right? So the number 1, like in the O1, that signifies that it's a fixed number, not necessarily one single operation, but rather like a number of operations that does not change the input size. Did I make that sense? Maybe I should put that. Yeah, wait, now let's do this. Oh my God, Andres. You were gonna do just talking. Okay. We'll do this anyway. What the heck? From input. From input. Like this. So the let's say like this. In signifies a fixed value. Oops, sorry, but not a necessarily one single operation. Yeah, I guess that's it. If I can still remember. I gotta, man, I've got good memories too, man. My memory is like, sometimes great. Most of the time it's great, but still, there's some days when, nope, that's not what I want. That one. Okay, how about we save this? What else can we talk about? So okay, how about we talk about the efficiency? So this is like the most efficient type of time complexities, as its performance scale perfectly. Yeah, that's it. So we could say, ooh, I'm not even doing this right. Something's wrong. Let me see. Oh, okay. So I could say efficiency. Alright, so I could say this is the most efficient type of time complexity. I know. You're like, it's confusing, get it, but just listen to it a few times. As performance scales perfectly. Perfectly done. All right, man. So the common example of an O1 operation, and I'm gonna again, is accessing the array, right? I mean, you could do. Let me see. I could just say common examples. How about that? An array element. No, common examples of a one. No, common examples of operations. That sounds more better. And then you could say, number first one is accessing, right? An array, because that's what I was talking about, element. And so direct accessing that element, the index is 0, right? It's like the classic. So when you do this, array, this is how you're getting that first one, right? Or the second one. Oh, maybe I can make that into let's put a variable. Oh, don't mess with that. Don't mess with that thing. Don't play with that thing. Don't play with it. Right? So that accessing the element like that, right? It's quick. It's like the classic way. And since the computer can calculate the memory address of the ith element instantly, by using that basic address, because remember in the arrays of 0, 1, 2, it's fast, it's very fast. It takes the same amount of time regardless of how many elements that you have in that array, man. So the basic arithmetic and assignment, simple operation like adding two numbers or assigning a value to a variable are all one. So if you do this, I guess I can kind of put it over here too, together, right? X equals 5 plus, I don't know, 5. And then you say Y, remember we've seen this before, equals to Z. Right, remember that one? I think, how do we put this? Let me just do this just in case. You say, oh, you forgot to say, I'm just giving you, you know. So if you do like, that will be the mathematical and the assignment. So I guess that will be 0. You know, how about we just do that? Let's just say that this is the second one, basic arithmetic, like this, and assignment. How about that? Assignment. All right. So that's all one. That's all one. So I'm gonna say is. I know I'm repeating it, but that's all one. And then you got the, what else do we talk about? And we got like the how you insert and delete, right? Because you're gonna be able to do a lot of these things. That's why I'm not gonna break it down to, because you're gonna be doing like inserting, right? Slash deleting, because that's what pop and push does, into a linked list, and we're gonna be talking about that later. At the head, you know, because that's what happens when you use like a linked list. It's basically an array. It's just differently. Wish I had the drawing that I can show you. So when you have a pointer like to the head of a linked list, I'm gonna go straight. Listen, I'm only telling you some of these things real quick because we're talking about it. But the actual details is coming in other videos. Okay. So when you have like a pointer to the head of a linked list, it's like a list. It's like a kind of like a stack, but it's a list. But it's I mean, look at it this way. It looks like there's a box. You put something in, then you have a little arrow pointing to the next box, and another arrow pointing to the next box. That's how you have to kind of look at it. So inserting a new node at the beginning involves only a few pointer manipulation. You know, like which is a fixed number of steps. Like change the new node's next pointer, because you can change, because you can point to that first box and say, oh, and then say I'm going to show you what I'm talking about in a bit. And in the current head, so you can change the list in the head and the pointer to the new node. So and that I'm going to show you in a second, because right now we're like in the array part, but I will do that. And plus you got that hash table, that lookups on average retrieving value from a hash map. It's kind of like a table basically. It's actually I'll show you this because I don't want to go too quick, but retrieving a value from a hash map or hash table, like I always talk about, by its key is an O1 too. So it's just a calculation. So it doesn't matter if you use tree, this and that. It depends on how the operation is, and if it's simple, and it didn't change much. It doesn't matter if you got like a million people or a million what is that element. The operation will always be an O1 because it was simple. It was fast. It's when you're changing to different things that say, oh, now you're taking a little bit more time, and that O1 becomes something else. Yeah, I get it. Directly, so the hash function, right, directly computes the potential location. It's like a bucket of values. And in that worst case scenario, right, due to like some kind of collision, this can degrade it to ON, which is crazy. But I will be showing you that, you know, in another thing. So if you do like the loop block, like the loop flow, remember the for loop stuff? Okay, let me just put it over here. let's just put here about we'll say, we just say 4 point. We'll just say loop flow. You know, like a for loop. For. I'm gonna put it in a block like that. Okay. And that's like a block of code, right? And we just saw that a little while ago, right here, right here. Well, this is an if, but same, kind of like the same idea. That would be a 4-1 too. So if you kind of did it like this, look, I'll show you. I'm gonna put it right here. Let's say we did a 4 like this, dollar. Where is it? Dollar. Let's say I, and that equals 0. You see how this works, right? So you say dollar I. Is it greater than 3? Remember that one? And then you say dollar I, and then you put that plus plus. Remember that one? That's the for loop. And then you, of course, you got your little brackets, right? Your little squiggy brackets, the curly brackets, like we call it. And then let's say you want to do an echo like this. You say echo, and then you say counting. Yeah, I can't believe my ribs hurt. I, like this, right? So we go like this. So what that does is it executes 3 times. Because you got this here. Look, it's going to execute it 3 times. Let's put it down over here. We'll say this executes. This is terrible. Executes. Man, I'm really hurting. Almost there. What did I do that was so 0, comma 1 and comma 2. That's it. And let's make this a little smaller. See, and that will become an 01. Yes, the code, I'm going to put it here. Yes. That code that you just saw is considered a 01. Constant change. Time, I mean. Constant time. And then you have, then you start asking yourself, but why it's this, why it's all 1, right? Because I was like, man, but why? Because the big O notation just describes how the execution time of algorithm grows. That's it. As the input size grows, the end, remember, input end. Then in the code that I just provided, right, it's execute 3 times, but that's it. It's simple. It's nothing. You're not for looping and then doing the whole other stuff too. And now it becomes something else. So when you explain, oh, it's on 01, and say, okay, good, that's just good. So the loop in this case, right? That, where is it? That loop that we just saw, that runs a fixed number of times, right? 3 times, because I said 3 right here. That's simple. If it's like a million, it still be simple too. So that'd be a 1. Still be a 1. Which is independent of any variable input size, because we're just talking about this looping part right here. This loop. It's just a way of, I don't know, it's just a way of simple. Now, since the number of operation doesn't change, right, regardless of how large that input could be, just like I just mentioned, the algorithm is said to have constant time and complexity over 1. So it doesn't matter, it just becomes 01. So if n were used as a loop boundary, like it would be O n linear. What? No, dog, don't do that. Linear time, because right now we don't, like if I took this, let's see if I wrote this right here. Maybe I should make this more clear, because now I'm getting a little off here. Let's say how about if we just say, what should we say? Okay, let's say since the number, let's just put that down, of operations doesn't, even to this day, it's still confusing. Change regardless of how, I think I mentioned that already, how large the input could be, right? Could be. So the algorithm, that's all right. Something's missing. Where is it? Where the hell did I put it? Algorithm. Man, why do I get that blackout sometimes? Algorithm. So the algorithm, right, is set to have constants, time complexity. There's a lot of typing. You should have just had this thing worked out already. I'm not complaining, guys. It's just I don't want to get you guys bored. So it will be something like, again, so if you say like that, if like the end where were used, right? So if it was used as the loop, and I'll show you in a second what I'm talking about, the boundaries. When you're not watching Christmas movies, like for, I'm gonna put this EG, whatever the heck that. Let's say like for a $4, what is it? Oh man, I'm messing this up. What is it that I use here? Oh, here we go. 4i. This thing should be close together. How about if we do this? Singing the song. Okay, here goes. So what I do is I'll change this. I'll say with I. It says and, but then I'll make this. Where are we? 3. Now we're changing it a little bit because now you gotta go a little extra step now. Now you gotta go get that information. And right? So then it becomes, well, because we don't know what number it is. We don't know what that is. So that will become, so then, let me see, something. So then it would become, it would be, how about we do that? It would be O end, because we don't know. See, over here we kind of knew it's just a one way. This one, you're doing this, and this is just a one operation. And if this number was huge, it doesn't matter. It's 2 or 1. But now we don't know. Now we're getting information from here. Where are we? N. Now we're getting, we don't know. What was N? What was N? Right? So now it becomes linear. Yeah, maybe I should write that down. Then it becomes linear. Time. So if I kind of went like, maybe I should just take that piece. Why am I repeating myself? Why are you doing this, sir? Oh yeah, by the way, guys, my grandniece, yeah, had a baby boy, 6 pounds. It's beautiful. And then we could put this over here. It's obviously a really happy guy, It's exciting because it's all about family, right? Anyway, so we go here. We could just put a whole bunch of stuff. Like over here, you could do anything you want, right? Like some constant. Man, I feel like eating. Don't you? Some constant time, And now this becomes an ON. That's what that is. So an ON. So if you do, like if you start playing around with, let's put a line here so we kind of separate some of these things. So if we do like a function call flow, like the control transfer and then returns, you know, something, like you could put like over here some kind of function that would, like some kind of function, like if I kind of did calculate underscore an area. It's like a common thing, right? Dollar width, then I say comma and dollar height. Halloween, guys, Halloween. And then you go like this, you go like this. Yeah, I love Halloween. I used to dress when I had that big house. I used to dress the front of it with the spookiness and stuff. And one day my son was, this when he was young, he would get into a costume and stay in the corner with all the plants and stuff. And I had stuff. Man, we so many people that used to go there, trick or treat, and then he would pop out and people would be screaming. Oh my God, that was a great time. So we go return the dollar width like this, and then we say, remember I told you, man, I'm trying to teach you this like if you're sitting right next to me, so we'll have some stories to tell you. I'm waiting for you to tell me a story. Maybe you should put it down in the comment below if you had those kind of moments. So if you do this, right, and then you say like the area, let's see, where are we? We could kind of say, I don't know, dollar, you know how you do this thing? Dollar equals area, bitty, 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 bitty. And then you just say, what's the name here? I'm trying to do these videos before my wife shows up, because she always ruins my videos. And then we go like this, and we go 5, comma, I don't know, 10, 15, doesn't matter. No. So this, right, let me put this over here. So this controls, look, this controls the jumps to the function. Because when you do that, right, you're calling the function or so this controls the function, then returns, what was going to return here, feature, and returns 50, right? Returns 50. And then let's jump down to this one. Maybe I should put it over here. Maybe, let me see, I'll put it over here like this. Because, you know, like this, because it returns 50. So it would be O end. So that's linear time. And then you can move, what is that? What are we doing here? What is that smell? Don't tell me my dog did the number. Echo equals the area, like this, and you can just say, how we do it now? Like this. Let's put a little space there. That's for you. We're not trying these things because I'm just giving you so that way you can, you know, try it when you get to the, because when we do the other stuff that I'm talking about, it's going to have the examples. That's when we're going to try all these things. Like this. How about like this? Singing the song and singing the song. Okay. And of course you close it, right? That's how you do it. You open it. Did I open this? Did I open this? I guess not. Oh, you know the story. You open it, you have to close it up. Right? So that becomes linear time. So the flow is that it checks the if and then when the time comes, or when you do the, I'm talking about the stuff that we were doing before. Where is it? See, right here. So when you do that, right, that executes the different things, but it's only regular stuff. But if you put the loops, like when you do the loops, it becomes like it loops around 3 times, right? That when you, so that when you put the loop within here, so where is it? Where's the loop? the main loop right here. So if you call in these guys, this thing here, put it inside, and you know how you call it, like these things here. So if you pull it, I know I'm got them separate right now, but if you pull it in there, right, then when it calls the calculated underscore area function, then finally prints it out, that will still become an ON. Now there's another thing called the ON2, and that's like the time, like this one that's, I'm thinking about it, let's separate this a little bit. Oh man, I can't believe it, man, my ribs really hurts. What did I do? Let's save this, because I want to give it to you guys. And then when we do the other thing that I was telling you about with more, then that will help you out, understand. So if you did like the O, like this, look, remember I was telling you with the power, where is the cat? There it goes. With the power 2, that is the time. This is like the time complexity. I mean, I should write this down better. Often, let me move this. It's getting to me too painful. It's associated with nested stuff. Maybe I should start talking about the nesting part. I mean, because see, when you do these kind of things, when you do this type of thing, and then you put this inside, this should not go in there, but when you're doing these calculation parts, this in here, you're actually what you would call it, nest looping. It's part of like a loop, you know. But so let me see. It's what I want to say. I want to say something, but I can't. Let's see. But associated with nested loops. Yeah, how about we do it like that? Yeah, that would be something more nested loops. And then you say not only in PHP, because we'll do that, but in computer science, you know. Generally, really. Boom. So when you understand this part, so if you understand this, right? See this ON, the quadratic time. It's a weird name. That ON2, that pronounces that means like it's the n square. It's like the, let me see, maybe I should just put it here. Oh boy, I think I must have eaten something. Didn't agree with me. Where is it? What do I want to say here? The ON is a okay, we'll go like this. It's pronounced. Maybe I should say pronounced as big O of n square. That was silly. Like that. Let's put this here. So it's like a classification. Is a classification of an algorithm. Oh wait a minute. Algorithms. Efficiency. Yeah, that's it. Efficiency. Especially its time complexity. do you think? Don't worry. Just keep reading it, look at it, listen to what I'm saying, and then we'll say so what does that mean? That quadratic scaling. That's when let me write it down here. Quadratic scaling. Now the time required to run the algorithm is proportional to the square. That's what I'm going to say. The size n. So the example is that if you double the input size, like the n2, the execution time will increase by a factor of 4, right? So that becomes like n caret 2, the square of 2, which is weird, right? So why nest loop results is on2 is because a nested loop is a common structure that leads to an on because if you, let's say you got a nested one loop and then you got another nested loop and then that loop has different arrays and stuff, that becomes a heavy duty complexity. So then it becomes like a square, you're squaring it up. So when the inner loop runs at a full complement of times, like say when it runs like, I don't know, so let's say you got a loop that runs 10, but within that loop you got another loop. Oh my god. So that runs another loop, right? So then, what was I saying? See, I got a little pain in the chest, that's why I had to stop for a second. Let's see, so when you run a loop and it's like a 10, and you run another loop inside, and within that 2 you got 10, right? So the inner loop runs a number of times. So each iteration is an outer loop from the outer loop. So in other words, you're looping inside, and then comes the next one, which is the out, then comes the inside. Then that becomes a heavy duty one, so that becomes an n squared 2. So if you're like, maybe I should just write it down here. Yeah, but I'm doing too good. Okay, let's see, check out this called pairs. Then you say dollar list. What's going on over there? Let's put this in here. And let's say we do $n equals count. Remember the count that we been using before? Listen like that. I should push this over. Maybe. There you go. And then you got within there that function, right? You got a for loop. So you could say $4. Let me see. $I equals 0. Remember that one we were using before? I and $n. Remember that one? And then you say $I and then the plus one. Remember that one? We talked about this before. Let's do this. What the heck, man? I wonder if I can push this at the same. Yeah, that's cool. So the outer loop, right, will run a certain amount of time, the n time, right? And then the inner loop runs the n time too for each outer loop. So if you ran like that one and you put in another loop inside, let's see. I know it's going to be a little complicated, but so if you saw 4 and then you say that, this is actually, by doing this step, you can actually do, sorts and stuff. And then you say $J, and that will be, is it greater? I mean, less than $N. So we don't know N, right? We don't know what that is yet. So we say $J plus plus, right? Now it increases by 1. Then you go like this, and you bring it down here. And then you say if. Now you're going to do another thing too. You know, you're going to say, you're going to take a branch, right? But in this case, it's just one branch. So you're going to say if, and then you're going to say $list. Because now you're checking your list. That's your that's not how you do it. $I, like this. And this is, of course, the strict equal signs. Remember that one? We talked about that. And then you say list, and then you say $J. And then what happens is you say and, where is it? That's it. And then you say $I not equals, let's say, double, J. Then you go like this. So then you go in there and you just want to echo. Just echo the stupid thing. Found a, what I'm finding. Let's say, okay, found a duplicate. That will be a good one. Duplicate pair. And then you could say, you could do, remember I talked to you, you could do the, this here. You can kind of do this. Remember I showed you guys how to do this? This will work too. $I. And then the bracket like this. That will work. You don't need to do that, but that also will work. I don't know some reason why we would do that sometimes. So we got 1, 2, and 3. So we get this done. That's part of that. That's part of that. That's 4 of them. Right? So when you do this, like the outer loop, right? This outer loop right here, it's going to run some number of times. But at the beginning, it's only going to run, I guess, the one time. Jumps over here. And then this is going to run as, like the inner loop will run the n times for each of those n outer loops. So, you know, so if you got 10 here and you got 10 here, this one would do 1 first, and then you're going to go through all 10. Then comes 2, and then you do it again, like that. Man, I don't know what's going on here. So anyway, so the total numbers of operation is approximately n times. So that's why they call it the n like this. They'll do it like this. N equals n caret 2. Like that. So therefore the pattern, right? The actual pattern. The pattern. Maybe, yeah, that's a good idea. Like regardless of the whatever language you're using, Python, JavaScript. Maybe we should put it down anyway. Language, like PHP. What is it? Python. I had a chance to learn that language. I'm learning it now, but there was a chance that I had to do it. I should have had it done. This would be Java and etc. It doesn't matter really, right? And that so it's classified. I'm gonna move it over here. Is classified as O n the power of 2. Where are we? That's it. Strange, right? Let me save this. It would be a shame for We're losing this stuff. So the fine point is that while nested loops are a primary example of the where the ON square root is, come from not all ON square algorithms use the nested loops, and not all nested loops are ON squared. So however, for a typical case like in a PHP, elsewhere, or a pair of loops iterating over the full input size is indeed ON, which is that. Let's move on. What else can we talk about? I had a list that I should have pulled out. So the single linked list, remember that we talked about it? So a single linked list is, I should have mentioned did I mention that? I should have did that. Oh, because I'm actually explaining the O notation and the actual data structure stuff will come in once we do a little bit of this, okay? So that's like it's like a sequential data structure. We're gonna be talking about that. You'll see. And where each element called let's go over here, a node. Remember that one? Node. And that contains data. That's it, right? And a reference. A reference, which is like a pointer, or a pointer. Maybe I should just write it down. To the next node in I can't believe it, I'm falling asleep, guys. Okay, let me spell that. Okay, let's see, sequence. What? What's going on here? Trace, wake up. Sequence. Okay, that sounds good. What? That ain't right. Oh man. So like for example of a linked list, right? The represents the number like 10, 20, 30 that will look like, right? So the first node holds like, let's say the data 10, and it points to like the next node over, and that will be 20, right? So you tell it, then the second node holds 20, but it also points to 30. So the third node holds 30 and points to null or none, indicating the end of a list. It's weird, right? It's all these things, arrays are, for me, it's always considered a list. I mean, array and all of these things are like in memory, but the list and stuff is a little different, but it's still in memory. So it's like, in other words, like, you know how you go to the website and you hit this and it takes you to the next one, or you hit this back and it takes you to the next one coming, and this one goes, you hit it 1, 2, or 3, and it skips 1, 2, and 3. That's what this is for. That's just what this is for. So if you create a node by defining a class, remember how we did the class from before? Let me write that down so that way you get it. PHP. So you could say you create a node by defining a class. Remember how we did a class? To hold the data and the pointer to the next node. Excuse me guys. I'm in the middle of a video, so I'll call you. Come talk to you later. Okay, sorry guys. Okay. So there you have it. So then if we do the close, right, the class, remember the class? We go class, then we say node, right, this is how we could do it. And then we go like here, and then we say, remember how we did that? Public, remember that? And then we say data, that's public, right? And then you say another, oh, excuse me, public. And then we're gonna say, oh man, I can't believe it. So it was true. The dog just did a number on the. Oh. Well, guys, I'm gonna have to take it on the next video because right now my dog just did a number. Okay. Too much interruption, but maybe let me just finish this part here. Public. This will be your public function. Remember how we did the construct? Remember that one? Construct. And then you put the dollar data like this. Oh my god, I smell. Oh boy. And then you say, remember how we did this? Dollar, ooh, what is it? Dollar this. Then you got a little rocket, right? A little rocket. Then you say the data equals to dollar. Oh my god. Data, sorry guys. Then you say this. And then you say next. This is your next. This was jumps to the next. Let's put it together. And then you're going to say, well, that's equal to no, because that's going to be like the last part, right? No. Like that. And this in, I'm going to put it over here. I'm going to say oh my god. Initialize. He knows better, but I don't know. I thought he must have ate something that's just no good. Oh man. Well, you know how it is. Pets, family too. Let me see. So we go like this, and of course is one more, right? Close that one up. This one belongs to that one. This one belongs to that one. So I'm gonna have to move this one a little bit that way, like that. See? So when you want to create an instance of it, right? When you want to create an instance, how about if we just put it here? Let's say create an instance. Remember how we did that? Of a node. All you have to do is say $new node, and that's equals to, remember how we created new node, because that's, and we're gonna send it to 42. Remember that? And that 42 is gonna end up in here, and then it goes in here, which goes right back in here. Okay, so that's how that works. Remember that? And then we're gonna say $new node. Oh man, I gotta open that Windows. Node. What was I doing here? No, that's not what I was doing. I was starting to say that it's now. Man, I fell asleep there for a second. It holds the number 42, just like I said, right? And its next pointer, which is no, which is okay. Let's save this. Because we don't want to lose this, any of this. Whew. So. And then what we're gonna do is after this we're gonna leave now, right? We're gonna leave now, and I'm gonna come back and it'll be the video 112, but this time will be 112B. I have to cut it because I have to walk this dog. The wife is coming and he did the number. I gotta pick this up before she comes. You know how it is. Okay, so hey, give me a thumbs up so far if you like it, and give me a comment. Please subscribe to me, and until next time, a good night.